Okay, welcome back. In this video, I'm going to describe some of the trigonometric identities. There's a whole bunch of these. There's just pages and pages of trigonometric identities, and you're not going to need all of them. You are going to need some of them. And the ones that we'll use the most are the ones I'm going to go through here. The first trig identity is the identity that says that tan of x is sine of x over cosine of x. And I'll explain where that comes from. Sine of x is opposite over hypotenuse. Cosine of x is adjacent over hypotenuse. What happens if we divide them? What happens if we do sine of x divided by cosine of x? So that's going to be opposite over hypotenuse divided by adjacent over hypotenuse. I'm going to switch that division into multiplication by the reciprocal. So multiply by hypotenuse over adjacent. The opposite on, what am I doing? The hypotenuse on the top cancels with the hypotenuse on the bottom. And we end up with opposite over adjacent, which is the same thing as tan. So that's where this identity comes from. Just that relationship between the ratios of the side lengths of the triangle. Next identity, sine squared x plus cos squared x equals 1. We're going to use this one quite a bit, and I'll explain where it comes from. So I'm going to draw a triangle. I'm going to call this side, let's see, I'm going to call it L. I'll call it L. I'll call this one W. And then I'll call this one H. And then this down here I'll call X for the angle. Then sine of X is equal to opposite over hypotenuse, which is L over H. Cosine of x is equal to adjacent over hypotenuse, which is W over H. What happens if we add them together after being squared? Sine squared of x plus cos squared of x. Well, that's going to be L over H all squared plus W over H all squared. So L squared plus W squared all over H squared. We can add the numerators together because they have a common denominator. But wait a second. Pythagorean theorem says that H squared is equal to L squared plus W squared. So we have H squared over H squared. Which is equal to 1. So that's where that identity comes from. Sine squared x plus cos squared x is equal to 1 for any x, for any angle. Okay, the next trig identity that we're going to use is the sine of 2x identity. The sine of 2x is 2 sine x cosine x. Now where this comes from, it's from the sine of a plus b formula. Sine of a plus b is sine a cosine b plus sine b cosine a. Now what if we do a sine of x plus x? replacing the a with x and the b with x. So we're going to have sine x cosine x plus sine x cosine x. They're both the same thing. We have an apple plus another apple, so that's going to be 2 apples. So 2 sine x cosine x. And that's that trig identity. As a comment, the proof that the sine of a plus b is sine a cos b plus sine b cos a. There's a few proofs, but I think one of the best ones is the geometric or the visual proof. There's a whole bunch of them on YouTube. I don't want to reproduce them. I don't think I can do as good of a job, especially as the one that is presented on Khan Academy. So I've put the link here. If you've never seen where this formula has come from, if it's just given to you as a formula once, grade 10, there it is. You ever saw the geometry, I recommend just viewing the video. It is a bit long as well. That said, you're not going to need that formula for this course. If you're following up with Calculus 1301 or 1501, you're going to need the sine of a plus b, the cos of a plus b, and the sine and cos of a minus b formulas for that course. But for this course, we're just going to use one special case of this, the sine of x plus x, or the sine of 2x, which I should actually write down. Sine of x plus x is sine of 2x. Okay, and then I'll do the next trig identities in another video. I'm trying to keep these short.